Okay, so this problem, I've got a 5 kilogram block pushed 3 meters at a constant velocity, that's important, up a vertical wall by a constant force applied at an angle of 30 degrees with the horizontal as shown in the figure. I want the work done by the force on the block. Okay, so work, I know work is force times distance basically, right? And so work is involving forces, so we should probably start by drawing a free body diagram, right? If you see forces, start by drawing free body diagrams. So there's the weight of the block, right? So this is a block that's pushed against a wall, so gravity's pulling down. So I've got the gravitational force, and then I've got, because the block is being pushed upwards, that means friction is pushing against it, right? As the block goes that way, friction's opposing it. So the frictional force will also be pointing down. And what else? I have the normal force from the wall. The wall is pushing back this way, so that's a normal force. And what else do I have? Then I have this force. So I'm going to break this force into its components, right? So this force here, I'm going to break into F cosine 30, and I'm going to break it into F sine 30, right? So F cosine 30 is here, F cosine 30, and my upwards one is going to be F sine 30. Okay, so I want the work done by the force on the block. So I need to figure out the total force acting on the block, right? So let's start by writing our equations from this, right? So I'm going to write a y equation. Net force in the y, it's going a constant speed, so both of these are going to be 0. Net force in the x is also going to be 0. So the y is frictional force plus Fg minus F, what is that? That's just F sine 30. That's my sine component, so it's these. And then my x is just these two are equal to each other. So that's F in minus F cosine 30. Okay, so this tells me that F in equals F cosine 30. Okay, so there's one. Now let's look at this equation. So this equation right here says that F plus Fg equals F sine 30. So Ff plus Fg equals F sine 30. So that means, okay, so now if I want to get F, I can get frictional force, right? So frictional force is, this is coefficient times normal force. And Fg is mass times g, right? So I can plug these two in, and I can say that mu Fn plus mg equals F sine 30. Okay. So from here, okay, I know what Fn is, look, so I know this. I can plug this into here. So I can say mu times F cosine 30 plus mg equals F sine 30. Okay, so I'm trying to get F. If I could get F, then I can solve for work, right? Got to figure out F because I'm not given F. Okay, so let's combine these things. I'm going to get my F's on the same side. So I'm going to subtract F cosine 30 from both sides. Right? So mu, let's see, mg equals F sine 30 minus mu times F cosine 30. Okay, and now I can pull the F out because there's an F in both of these, right? So that's the same thing as mg equals F times sine 30 minus mu cosine 30. Oh, and now I can just divide, right? I distributed, right, because if I distribute that F in, so I can pull that out. And so mg over sine 30 minus mu cosine 30 equals F. and I can solve for my force using this, right? And so once I know, make that a little neater. Once I know F, right, if I take this number, I know that work is force times distance. So I can plug F in here, and 3 meters is my distance, so 3 meters can go in here. And then remember, work is only, it's a dot product. It's only the amount of the force that went this way, right? So it's only the component that's going along the wall. So that's the sine component. So I need to also do this times sine 30. So if I do this, if I plug in this for F, if I solve this for F, plug in here, plug in my distance here, and multiply it by the sine of my angle, that'll give me the work done by the block, right? So I need all of this to get the work done by the block. And then the rest of this is fairly easy. So the work done by gravity, work is just force times distance, right? So the work done by gravity, let me say it this way, the work done by gravity is going to equal the force of gravity times the distance the block moved, right? And it's all in the same direction. So the force due to gravity is just the weight of the block, which is mg. And then distance of the block is the distance it moved. So my work would just be the weight times the distance, right? Easy. Magnitude of the normal force between the block and the wall. Oh, wow. It helps to draw free body diagrams. Because when I draw my free body diagram, I can see that these two forces are the same, right? So from my x equation, I have Fn minus F cosine theta equals 0. So Fn equals F cosine 30. Right, so for this one, my normal force is equal to F cosine 30. Right, whatever F was. And I already figured out F in part A, right? So remember this right here gave me F. So for part 1, I had to plug F in here. So for part 3, I can do the same thing. I can take the F that I got here and plug it in here, and that'll give me my normal force. So again, start by drawing a free body diagram and equations, and then from there it was just algebra to figure out the stuff that I need.